Welcome to AI Frontiers, your guided tour through the most exciting new research in artificial intelligence. This episode is titled Vision Unlocked, AI's New Eyes, and our focus is synthesizing insights from 17 research papers published on May 23, 2025. These papers represent the cutting edge of computer vision, a field at the intersection of computer science and artificial intelligence, dedicated to enabling machines to perceive and interpret the visual world. In this episode, listeners can expect to explore breakthroughs in computer vision, review key advances and future directions, and gain insights tailored for researchers, students, and enthusiasts alike. Prepare to embark on a journey into the evolving landscape of machine perception, where algorithms and systems are fundamentally reshaping how machines see, understand, and interact with the world. This presentation provides an overview of our journey through the latest developments in computer vision. The session begins by setting the stage, addressing the foundational question of what computer vision is, and why it holds such significance in today's technological landscape. The narrative then surveys 5 dominant themes emerging from the 2025 research, offering a structured understanding of current trends. This is followed by deep dives into 3 standout papers that exemplify methodological innovation and transformative impact. Listeners will be guided through key findings, underlying methodologies, and the major challenges that remain. Finally, the episode concludes with recommendations for further learning and engagement, ensuring a clear pathway for those seeking to deepen their understanding of computer vision's frontiers. Computer vision is a pivotal discipline within computer science, enabling machines to interpret and understand images, videos, and 3-dimensional data. Its technologies power facial recognition systems that unlock devices, enhance medical imaging for earlier and more precise diagnoses, and drive autonomous vehicles by identifying pedestrians, traffic signs, and other vehicles in real time. Modern computer vision integrates seamlessly with complementary data modalities, such as text, audio, and sensor information, creating richer and more contextualized understanding. This integration drives automation, enhances safety, and fuels creativity across a wide range of industries. As a foundation of contemporary AI-driven digital interaction, computer vision is now central to how societies interact with technology, shaping workflows, safety systems, and creative tools. The first major research theme centers on generative AI, with a particular focus on diffusion models and video synthesis. Generative models are designed to create images, videos, and even 3-dimensional objects in response to various prompts, serving both creative and technical applications. Diffusion models have emerged as powerful tools, capable of producing detailed and high-fidelity outputs. For example, the work of Fang and colleagues introduces INF-LVG, a system that efficiently generates long, coherent videos by leveraging reinforcement learning for dynamic context selection. Similarly, Quassia and collaborators demonstrate the value of diffusion models in enhancing radar signal resolution, thus expanding the domain of generative AI beyond traditional visual tasks. Collectively, these advances underline how generative AI is fundamentally reshaping the ways in which machines create, perceive, and interact with visual information. The second research theme addresses robustness, fairness, and bias in vision systems. As computer vision technologies become increasingly integrated into critical real-world applications, concerns about fairness, ethical use, and privacy have taken center stage. Kakimi and colleagues reveal that deeper diffusion models possess a tendency to amplify biases present in the training data, raising important questions about the reliability and societal impact of generative AI. In response, Yo and collaborators introduce an interpretive framework that not only identifies but also corrects bias within model attention mechanisms, thus improving fairness and model trustworthiness. Bias mitigation strategies are shown to contribute directly to the reliability and ethical deployment of vision models. The focus on trust, security, and equitable outcomes is now a defining hallmark of state-of-the-art AI system design. The third theme emerging from the 2025 research is the integration of multiple modalities within computer vision systems. Modern vision models are no longer limited to processing images in isolation. Instead, they are increasingly capable of fusing information from language, audio, and sensor data. This multimodal approach allows for richer, more context-aware understanding and supports complex tasks such as hallucination reduction and unified anomaly detection across diverse domains. For instance, Cho and colleagues utilize attention-guided ensemble decoding to minimize hallucinations in large multimodal language models. Chen and team present a method for robust anomaly detection that adapts across different domains using visual perception prompts. Multimodal fusion is thus recognized as a key enabler for interactive, adaptive, and intelligent systems, marking a critical step toward advanced machine intelligence. Benchmarking, evaluation, and real-time deployment compose the fourth research theme. The development of domain-specific benchmarks and evaluation frameworks is crucial for assessing and driving robustness and scalability in computer vision models. Wang and collaborators introduce MODEM, a comprehensive benchmark for restoring images affected by adverse weather conditions, ensuring models can handle real-world artifacts. Zhu's Orion Bench evaluates object detection in complex infographics, challenging models to interpret human-recognizable tasks. Song and colleagues present RARE, a framework for real-time traffic accident anticipation that achieves state-of-the-art performance with minimal latency. Liu and co-authors address the challenge of efficient analysis of gigapixel medical images, demonstrating transformative improvements in computational efficiency. Collectively, these contributions highlight the importance of rigorous evaluation tools in enabling robust, scalable, and practical AI deployments. The key findings from the 17 papers published in May 2025 reveal several transformative insights for computer vision. Fang and colleagues in InfLVG achieved significant progress in video generation, producing videos up to 9 times longer and more consistent than prior models. Hakemi's work demonstrates that while deeper diffusion models can amplify bias, targeted mitigation methods can effectively address this issue. Chen and team advance unified anomaly detection, significantly reducing both false negatives and false positives across multiple product classes. Yo and collaborators' targeted correction strategies yield substantial improvements in fairness and group accuracy in multimodal AI systems. Liu and the WSIG Mamba team deliver medical image analysis at just 1/7 the computational cost of traditional approaches, making advanced diagnostics far more accessible. These findings collectively define the current frontier in computer vision research. The methodologies driving progress in computer vision are diverse and sophisticated. Diffusion models, which iteratively refine random noise into highly detailed images or videos, have become foundational for generative tasks. Reinforcement learning techniques are employed to optimize context selection and action policies, as seen in video synthesis and other adaptive applications. Attention mechanisms, including transformers and their derivatives, allow models to focus on the most salient visual cues, enhancing interpretability and precision. Benchmarking with realistic and challenging datasets is essential for exposing both strengths and limitations of these models. Finally, knowledge distillation and feature reuse strategies are increasingly adopted to achieve high efficiency, enabling advanced computer vision systems to operate effectively in resource-constrained environments and in real time. One of the most influential papers is InfLVG by Fang and colleagues, which addresses the challenge of generating long, coherent videos from textual prompts. InfLVG distinguishes itself by implementing Group Relative Policy Optimization, or GRPO, a reinforcement learning algorithm that dynamically selects the most relevant context for each frame generation step. This approach eliminates the need for processing the entire video history and does not rely on massive datasets of long-form video. The result is a model capable of generating videos up to 9 times longer than previous baselines, with significant improvements in semantic consistency and visual quality. InfLVG's impact is especially pronounced in domains such as entertainment, simulation, and video-based artificial intelligence, where the ability to synthesize lengthy and coherent narratives represents a substantial advancement. The second spotlighted paper, Deeper Diffusion Models Amplify Bias by Hakemi and collaborators, investigates the implications of increasing architectural depth in diffusion-based generative models. The research reveals that deeper models, while capable of producing higher quality images, can inadvertently amplify biases present in the training data. To address this, the authors introduce a training-free mitigation strategy that bypasses selected network blocks during the denoising process, thereby increasing output diversity and fairness without the need for retraining. This approach is both efficient and effective, improving image quality and mitigating undesirable biases. The findings raise critical awareness of the risks associated with generative AI, particularly in creative and sensitive domains, and provide practical solutions for building more equitable and reliable models. The third paper of focus, WSIG Mamba by Liu and collaborators, presents a highly efficient framework for analyzing gigapixel-scale medical images. This approach combines graph neural networks with the Mamba state space model, yielding a hybrid architecture that captures complex spatial relationships while maintaining computational efficiency. The GMamba block enables message passing, graph scanning, and bidirectional state space modeling, allowing the system to match the accuracy of leading transformer-based models at just 1/7 of the computational cost. This innovation is particularly valuable for resource-limited clinical settings, where advanced diagnostic capabilities are needed, but infrastructure may be constrained. WSIG Mamba sets a new precedent for scalable hybrid computer vision architectures, broadening access to high-precision medical analysis. Looking ahead, several prominent future directions and open challenges can be identified within computer vision research. The integration of visual, linguistic, audio, and sensor data is expected to deepen, enabling models to reason over complex, heterogeneous information streams. Ongoing research into bias, fairness, and privacy will remain essential as models become more capable and are deployed in sensitive domains. Scalability and efficiency will continue to drive innovation, with democratization of vision tools necessitating advances in model compression, feature reuse, and resource-efficient design. The development of robust, real-world evaluation benchmarks will be critical for ensuring that models generalize beyond curated datasets. Finally, enhancing interpretability and aligning AI outputs with human values will be paramount, supporting greater trust and reliability as machine intelligence becomes increasingly influential in decision-making processes. The synthesis and review process for this episode involved a blend of advanced artificial intelligence and human expertise. Content was generated and summarized using GPT 4.1, supplemented with text-to-speech and image generation technologies provided by OpenAI. Each slide and summary was then reviewed by a human expert to ensure technical accuracy and clarity, though minor oversights may remain. All referenced research papers were published on May 23, 2025, and have been curated to provide a comprehensive view of the latest developments in computer vision. This approach combines the analytical power of AI with the discernment of human reviewers, delivering a trusted synthesis of cutting-edge research. Thank you for joining AI Frontiers as we explored the vision frontier. To stay informed about the latest breakthroughs in computer science and artificial intelligence, consider subscribing to our YouTube channel. Regular updates will keep you ahead in the fast-evolving fields of AI and computer vision. Engage with our growing community of curious minds and domain experts, and support our mission to deliver insightful and accessible content. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from archive preprint server. From neural networks to quantum computing, complex research is simplified so you can stay ahead. Whether developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by Archive Preprint Server.